Alright, so now we're going to start talking about capacitors. Now, the definition up here for capacitors is a device that can store electric charge. We've been talking a lot about charges and characteristics of charges and forces of charges. Well, now we're going to talk about, okay, storing a charge of some sort so that we can use it to power something later. Okay, so up here, I have a really brief description of what a capacitor is. It's generally made of two types of conducting materials, plates or sheets, something like that, that are very, very close but not touching. So this is not to scale, obviously, but let's say I've got these two little plates or sheets. Okay, each one of these would have an area of some sort, especially if it's like the sheet, it's fairly easy to come up with, and then they'd be some sort of distance apart. Now, most capacitors that you'll see aren't just big plate capacitors, although they could be, I guess. But most oftentimes you're going to see them like rolled together with something in between, something that does not conduct. That particular material is generally called a dielectric, so that it keeps those two conducting plates separate from each other. Okay. Now, I also want to bring up the point that we're going to start seeing some circuit diagrams with some pictures. Okay, so in a circuit diagram, which is just, a simplified version of electronic schematic, okay, you're going to see some symbols. So if you come across, and by the way, any spot like this I'm drawing along a line here, this is just a wire. So there could be a wire that is connected to these two parallel plates. Well, these are two parallel plates. In a picture, those two little parallel plates is known as a capacitor. Okay. Now, you might also see this symbol with a straight line and then a little curved line. It's the same thing. Now, I thought of something else that we should probably, we can start talking about, but if you see this symbol with a long line and a short line where it says positive and negative, that is a battery. So just so you're aware that these things are coming. Okay. Now, the formula for the capacitance of a capacitor is the charge per voltage, the charge per unit voltage. Okay, that would be coulombs per volt, or better known as what's called a farad, which gets the big symbol F. Now, common values of capacitance, things that you might see, might range all the way from 1 picofarad to about 1,000 microfarads. Okay, that's pretty common. Not to say that you can't be outside that range, but that's generally what it is. So, what exactly is capacitance based on? How do we dictate how much charge we can store in something? Well, if you just take a look at the picture up here, obviously, well, there's an area. Well, wherever there's an area, you could probably build up more charge. And then there's also a distance between them. Okay, so those things are going to be important here. So down here, I've got that capacitance is usually determined by the size, shape, and the positioning of the plates. Okay, so if you look at this equation, capacitance is equal to, now this little symbol I'll come back to in a second, but it's proportional, directly proportional to the area. So as the area goes up, the more charge you can store, the capacitance goes up. Okay. And then the capacitance is also affected by the distance between the plates, but the bigger the distance, the less you can store. So you ultimately want to get as big an area as you possibly can and get them as close as possible. That's how you're going to be able to get the biggest amount of capacitance. Okay. Now, this little symbol, this little fancy E with a little the little naught after it, is called the permittivity of free space. It's also sometimes called the vacuum permittivity. It doesn't really matter what exactly that is. It's a numerical constant. It's in your packets. You won't have to memorize it, but you should be aware of when to use it. So if you're trying to calculate the capacitance of something where you know the area and the distance between the plates, then don't forget that you have to use this particular number, 8.85 times 10 to the negative 12th coulombs squared per Newton times meters squared.